I'm Iraj Sodagar, multimedia architect with Microsoft, also MPEG-DASH subgroup chair, also president of Dash Industry Forum. First, let's introduce the panel. We start from here. Tell us who you are and what you do, briefly.
Rishi Swaminathan, I'm a principal scientist at Adobe Research. I primarily work on video systems, everything around video. I'm also one of the contributors and lead a new Dash spec called Dash over full duplex HTTP. And I'll be talking about HTTP 2.0 primarily.
So I'm Alex Giladi. I'm senior manager at Interdigital Communications. And I'm involved in Dash since 2009 as a contributor and spec editor in MPEG, as a contributor and vice chair of interoperability group in Dash Industry Forum, and as chair of SCT working group on Dash. Thank you.
I'm David Agronoff. I'm a lead architect for Cable Labs. We represent the interests of the cable industry around the world. We have members all over the United States, North America, South America, Europe, and Asia. And I work on all kinds of video projects, both traditional video and IP video. So I'm here to talk about Dash from a cable perspective.
Hello, my name is Stefan Leder. I'm CEO of Bitmovin. We actually deploy Dash systems today and have products in that field, and participated in the Dash standardization since the beginning and in the Dash GF, and somehow Dash addicted.
Thank you very much. So the format today is that I will give a very quick update where the standardization and consortium efforts are in 5 minutes. Then each panelist I will ask to talk about the area of interest, 5 to 6 minutes. Hopefully by finishing this presentations, we're going to have 15 minutes for questions and answers. Let me give you an update where Dash standardization are. As you know, the core standardization, the core spec standardization is done by MPEG, which is a subgroup of ISO IEC, JTC1, same group that developed all the codec standards. The first MPEG-DASH standards came in April 2012. We know that as first edition. Last year, in 2014, we published the second edition, which adds events and asset identifier, among other things. After that, we did the first amendment to the second editions, which defines extended profile. In fact, it defines how to use the tools in the second editions. Very recently, as of last meeting, we finalized the second amendments that add 3 new tools. SRD is a method to be able to stream tiles of the video at the same time, and it defines the relationship between those tiles. Flexible URL parameter insertion is a mechanism that allows the client to add their own parameters when they request segments from the server. So it's very useful for customizations, for target ad insertions. I think Alex may talk about that. And role extensions, there is a descriptor in Dash called roles that tells the nature of the content, different parts of the content. We extended that role to better support accessibility and hearing impaired. As of last meeting, also we started a new amendment, Amendment 3, that has several new technologies in it. Authentication and content access control is one. Anchoring using real-time wall clock. You can say start this MPD on Tuesday morning at 10 o'clock. So if it's a live broadcast or live streaming, you can say start from the exact moment of it to the client. Callback events is a mechanism to track what client is doing, especially when going over the ads. external MPD link is a method that allows to link different manifests with each other. Now you can point to external manifests. And period continuity is, again, a mechanism to show the properties of the signal when going over the period, these concepts of periods we had in Dash. As you can see, there are lots of new ideas being added, mainly driven by industry needs. They come back and ask us to add new features to enable more new use cases. Besides the core specification, 2 new parts also was introduced. One is server and network assisted streaming, so-called SAND. This is completely separate than the core specification, allows origin servers or caches to signal clients out of the band in the live manner to provide information about network characteristics. So it can help client to improve the streamings in a dynamic fashion. For instance, one CDN goes down, another CDN gets introduced, the client can switch and get those informations in real time. And full duplex dash, it's using dash using full duplex protocols, which is going to talk about it, so I'm not going to go in detail. The point, again, is that there are several activities going on in Dash, content aggregation and playback control. Another one, just a panel discussions before this, they were talking about the importance of content aggregations and putting different channels together or programs together, creating a channel. This is basically right now being addressed in Dash terms. This is the core standardization. Now we have also Dash Industry Forum, which consists of 79 company members. The purpose of Industry Forum is to define constraints, limit the number of interoperability points. So when the industry deploys, everybody deploys the same thing, so interoperability will be achieved. Devices, clients work with the services and with the authoring tools and so on. Also provides the test vectors and conformance softwares and other tools for it. So at Dash Industry Forum, we recently published IOP version 3, which in past we were supporting AVC. Now we also added HEVC for streaming. It has an enhanced mode for live streaming using the events, and also it has lots of ad insertion tools that I hope Alex talked about it. We have also conformance software and test suites being added. We have some of those, and we are completing those for version 3. And as you can see, there are going to be new work items continued on in future. UHD, HDR is a huge discussion. Object-based audio coding, AC4 and MPEG-DASH audio is being added, and several other projects. Tamper-proofing, basically making sure that the man in the middle cannot attack the streams. Authentication, similar to the work that's, or along the work is done in MPEG, and also content publishing guidelines. We also have the Dash.js projects, which is an open source JavaScript player. I encourage you guys, go to Jeff Tapper's talk this afternoon on the players. Part of that talk will cover Dash.js. So if you want to get more information, please go at dashif.org. The idea was for you guys to have an idea of what activity going on in terms of the standardization. Now I would like to ask each panel member to talk about one topic. The main thing is, what can we do with Dash that you cannot do with other streaming formats?
Thanks, Siraj. So I'll talk about the full duplex protocols like HTTP 2.0 and WebSockets, that how Dash is going to use them in the next version, or as Siraj called it, Dash extensions. So normally, most of the streaming systems used to be push-based, so the server decides when to push media to the client. With the advent of HTTP streaming, and particularly Dash, we are in the pull-based media consumption. Pull implies high source variability. What that means is that typically in HTTP streaming systems, we have multiple proxy tiers, and at least some of the HTTP servers along the way is going to be pretty dumb in the sense that they don't understand enough about the media or the sessions. And of course, there's the edge termination, which means that the last mile network and the network upstream is going to be very different, that you cannot predict intelligent behavior from these systems. So the high source variability causes considerable issues, and one of them is the latency in the network itself, particularly for live video streams, and I'll get to that. However, the biggest advantage, if you could go back a slide, the biggest advantage in the pull-based systems is that they are highly scalable, and of course that's why we all love Dash, mainly because of the HTTP streaming systems and the fact that the total cost of delivering video has come down considerably. Now, can push make a comeback and still have the same benefits as pull-based systems? That precisely is what Dash. Oh, go back a couple of slides.
John.
I just did it. Yeah. That's precisely what Dash over FTEdge is looking into. The two technologies that it's looking into is HTTP2 and WebSockets, and I'll particularly talk about how Dash is planning to use some aspects of HTTP2 in the context of live latency. So we all know that one of the complaints is that online live video streams are to be charitable 30 seconds, but it's in reality it's 1 or 2 minutes behind broadcast cable and terrestrial TV. Now, this is particularly a problem when something happens and people actually tweet or send Facebook updates before the online viewers see it, and I hate it. I don't know about you guys, but it's a big problem. Now, so what we set out doing is that, just to give you an idea, in a lab environment where you don't have speed of light issues, you don't have really the network variabilities that come along the way, for something using HTTP 1.1 and even Dash is about, at the minimum it's about 18-second latency for consistent playback. With HTTP2 technologies, particularly a technology called server push in HTTP2, we can achieve latencies around 3 seconds, and we can further take it down if the network is fairly stable. So with that motivation, I'll talk a little more about what HTTP2 does. HTTP2 was finalized the beginning of the year, and it introduced something called server push. In this technology, what you can do is that when a client requests for a particular asset, the server has the ability to push more than just the asset. So it can actually push associated resources with it. So we used this technique for Dash segments and intelligently, to bring down the latency considerably for live events. Typically, when you have really small segments, there's a request explosion. But using HTTP2, we keep the request explosion and general compatibility issues under check, achieving really, really low latencies. So this is how HTTP 1.1 system looks like. For every request, there is a response, or in other words, to get a response, you have to make a request. The extreme of that is that you can get one request and just the server can essentially send all the Dash segments for that request. What we are zeroing in on is something called K-push in the Dash extension called FTEdge, where we send K segments, which is a configurable number of segments for every request that comes in. What this does is that it appears the overhead is similar to having a segment that's as long as K, all of these K segments put together. But of course, you get the latency associated with just one segment out of that K. So go one more forward. So that's a sort of a live demo. And again, this is a crude lab environment demo where things are side by side. Of course, that doesn't mean that it doesn't go over the network. But what you can actually see is that the 3-second to 18-second latency difference. And I want to sort of introduce that and say this is what is coming in the Dash extensions to get you all excited about it.
Thank you, Alex.
Okay, so in this talk, I wanted to go over the evolution of ad insertion support in Dash from the very beginning to the upcoming version 3. In 1.0, we got the basics. We got the support for dynamic ad insertion. In version 2.0, we introduced very significant improvements and a completely new additional model. And in the end, I'll provide a preview of upcoming attractions in 3.0. So next slide. So here are the basics. So server-driven dynamic ad insertion, we had this from the beginning. This is something very simple and similar to what people do in HLS. So MPD, the Dash manifest, is a sequence of periods. And we can have either a fully specified period or a remote period, which is basically a URL to a fully specified period that is stored remotely. The URL, we call it Xlink URL. It can be resolved either at the beginning of time or in real time, which is very convenient for just-in-time decision. And translating the period structure into ads. So the main content is just a sequence of periods, sometimes interspersed with periods belonging to ads. Now, ad break is a remote period. We want to make up a complete break out of ad spots on the fly and then return it. And lastly, an ad always ends up being a fully specified period. It can be a remote period in the beginning. So this is all good. When the previous slide yet. So this is all good when we have a system that is not live. In live, we have our ad break location known only a few seconds ahead of time. So we need to keep updating the MPD in order to have all the information in time. So next slide, please. And in 2.0, one of the main use cases that we addressed was efficient ad insertion. And we introduced three major things that are related. First of all, events, then asset identifiers that group periods by content, and lastly, we did a significant overhaul of Xlink. So the most important of these are events. Events are timed messages, timed pieces of data that are embedded either in the media segments or into the MPD. We define several events that are handled by Dash clients, and the currently defined ones trigger MPD update. We have user-defined events that are basically transport mechanism for application-specific messages, and we'll see how important these are as well. But let's start from a huge efficiency problem that we're solving with Dash events. You have, in live case, a couple of seconds worth of early warning for an incoming ad. And if you want to handle this, you need to have update frequency of a couple of seconds. Now, the ad break, luckily, is still a relatively rare event. You can have 10 or 15 minutes without ads, but you will still be asking for a new MPD. So what we do is we use events to trigger MPD updates, and this way, instead of asking for an MPD 450 times, we can save the 449 and just ask it when we know that a new MPD is available. So and now for something completely different. Here we introduce a new ad insertion model that was added in 2.0 and was made possible by user-defined events. So this is something that should seem familiar to people who worked with Adobe HDS and with smooth streaming. What we have is everything is driven by an app or by a player. We have our content marked up with cues that contain parameters and timing information. Then the app, the player interacts with the Dash server, with the ad servers, and this interaction is driven by the queue messages. The queue messages arrive through user-defined events through Dash, but Dash is completely oblivious to their purpose or to any ad insertion functionality. So that's the basics. It's a dual client system, and what we did as MPEG, we introduced user-defined events. What we did as -IF and SCT, we specified the use of SCT 35 for the purpose. This used to be a standard for all the cable world, and we ported it into the OTT world. So next is targeting. So the original 1.0 and 2.0 didn't have too much beyond implicit reliance on HTTP cookies. In terms of 3.0, we have two upcoming technologies that should make targeting easier. We already have a technology for inserting custom parameters into MPD and segment requests, which was already mentioned by Raj. And this is something that we can generate on the client side, or we can have something assigned like client ID assigned by the server. Now, we also have an extension that is under consideration now that uses custom HTTP headers. So then, the next thing is actually getting paid. The previous two are not entirely getting us there. We need to report impressions to get paid, and we had no special provisions for this in 1.0. The simplest thing was to do logging at the CDN level. An interesting hack I've seen was use of remote period just in order to ping a tracking server and return an empty period. 2.0, again, user-defined events it helps us a lot. We're using IAB VAST, which has a vast amount of tracking functionality. We just embedded into the MPD using MPD events, and we rely on an external module that will work with it. The Dash client, again, is completely oblivious to this. And in 3.0, we realized that maybe we're requiring too much complexity. If you are using only a small subset of vast functionality, if you just want to say, here the ad has just started, or we're at 25%, or we just finished showing the ad, you don't need all the complexity. We just have a simple event that says, please issue HTTP GET to this URL at this time within the period, and completely forget about the return. So that's it as far as tracking is concerned. And since we're a little bit out of time, a brief summary. So we've seen that we have enough power tools to make interoperable ad insertion viable and efficient. So ad insertion is something like football. Everybody knows how to play it, but not everybody gets to the Champions League. We hope to get there. And we made a significant amount of improvements in 2.0, and 3.0 will be even better. So thank you.
Thank you.
And if people are interested how this really works, everybody is more than welcome to go to -if.org or to ask me after this session.
Thank you, Alex. David?
Thanks. So just go right to the next slide. I'm going to try to, in the spirit of Dash, I'm going to try to adapt my bit rate of my presentation within the time that we have. So I'm going to briefly, I'm going to talk about accessibility. It's really important for us in the cable industry because there's a lot of government regulation. There's a thing called Title VI, which sort of imposes some, in the United States, some standards about accessibility. And it could mean a lot of things to different people, but when I talk about it, I mean specifically captions for the hearing impaired, audio descriptions for the vision impaired, and for those who don't know, that's a special service where they actually insert descriptions of the action into the audio so that someone who can't actually see the television clearly can still know what's going on and follow the story. It's a great feature for those who have vision problems. And then also I'm going to include talking about subtitles or dubbed audio for people who don't understand the native language of the content. I'm sure you're all familiar with that. So the next slide, some legacy limitations. You know, a lot of these technologies were introduced with broadcast and cable using MPEG-2 transport stream, sometimes limited bandwidth for those services. Things like captions are decoded either at a television or at a set-top, so they're very static and they don't change very often because we're rolling out hardware that needs to accommodate for the technologies. The typical way to do captions, at least here in the United States, is with something called CEA 608 and then subsequently 708. CEA is Consumer Electronic Association, which governs how televisions are standards are introduced. And then audio is usually done. There's usually a primary audio track and a secondary audio program, which was great when you just had English and Spanish in the US. But then along came these video descriptions, and they started repurposing the secondary audio for that. So sometimes you don't get what you expect. And then the last two are just our UI issues. They're not specifically addressed with video streaming, but any accessibility solution needs to take into account UI as well as the video itself. So what MPEG-DASH did is came up with this role descriptor. So every adaptation set, every set of content in Dash can have a role descriptor which describes what it does. And there's more than I show here. These are the ones specifically related to accessibility. So captions, like I said before, for the hearing impaired, subtitles for language variations. And I think in other countries, subtitle is used synonymously with caption, but in the US it's not. And then dubbed for audio translations. And then new, just introduced in the last MPEG meeting was a few more items, which is descriptions, which I already talked about. It's an audio format. Sign, which is, I'm not going to talk too much about it, but it's an additional piece of video that shows someone actually signing the text of the audio. And then enhanced audio intelligibility. This is for people who actually have slight hearing problems and they just need an audio track that may be more clear. The actual dialogue may be enhanced at the expense of maybe some of the special effects, the sound effects and music. So the next, some technologies for captions and subtitles in use. There's a variety and probably more than I have here. Like I mentioned, CEA 608 and or 708. W3C has something called TTML, which is used on the web. It's also, there's a profile of it called SMPTE time text. There's 3GPP time text, which is slightly different, and WebVTT, which is used with HLS quite a bit. In addition to CEA 608, I think they use that as well quite a bit. So here's basically how it works. Each one of these boxes on the left side is an adaptation set. It may have one or more representations of that content, but that adaptation set is separated for each language and for each role that particular content plays. So we can select a piece of video. In this case, we're selecting the main video. We're selecting the main audio, which in this case is English, and we happen to be using a text track which has captions, which are also English in this case for this particular configuration. The next slide has a different configuration, and in here all we did was select through an application. Here we asked for the audio with the descriptions in place, also in English, and we changed it up to use the captions in Spanish. So actually those should have been subtitles in Spanish. But the point is that the application should, just like with a television today or a set-top box, should allow you to select these different features and hopefully even remember your preferences and have those built in, and then the dash MPD will let you identify which segments contain those attributes. The next piece is the slight variant in how CEA 608, 708 captions are handled, and it makes it a little awkward because they're actually embedded in the video itself when you use 608 or 708. There's a place in the picture data where that caption is embedded, so it won't come through in a dash presentation as a separate text representation. It'll just be part of the video. So in this case, we need to be able to identify and select the appropriate closed caption track. So the last slide here shows that we we use an accessibility descriptor in addition to the role descriptor. So the role descriptor will say we have video, but this accessibility video descriptor will specify that there is indeed 608 or 708 captions. There could be up to 4 608 channels or 16 708 services. They just have different terminology. And there will be a language mapping so that an application would be able to look at that descriptor and select the appropriate language without having to make the user try each one and guess. And so that's all I had to say about accessibility.
Thank you, David.
Sure.
And last not least, Stefan.
Yes, welcome. I'm talking about practical things we see in Dash deployments today and what are the benefits here and the improvements you can do with Dash versus other protocols. And here the most important thing is definitely the ecosystem of standards which has involved around MPEG-DASH. So after the release of the standard in 2012, also further standards hooked into MPEG-DASH, like HTML5 media source extensions, encrypted media extensions, in combination with common encryption for DOM, with HBB-TV 1.5 for smart TVs. So there's a whole ecosystem evolving, supporting MPEG-DASH, and of course the activities in the Dash AF industry forum with the specifications as well as with the reference clients. All that enables Dash deployments today without a problem. So we do that every day, and that's state of the art. Netflix is doing it, YouTube is doing it, but everybody else can do it as well. And it's maybe not completely possible to serve 100% Dash, but that's not the case with other formats as well. Our approach is to serve MPEG-DASH with a fallback to HLS for the iOS devices. Of course, that's a different ecosystem again with their ecosystem policies. And that's the reason you have to do that today. Hopefully that changes in the future. And with that, we end up with about 80% MPEG-DASH deployments, users getting MPEG-DASH content. In certain deployments, we end up in 90–95% of the users getting Dash content to the devices, and a small portion going for HLS. On the next slide, can we go on? On the next slide, we have some customer case studies which deploy Dash for different scenarios. For example, the Austrian Netflix equivalent Flimit for on-demand content on any type of devices, desktop, mobile, and smart TVs. Corona Hit, music television type of content for 24/7 live streaming. About 90% of the users are served with Dash today, and where you can also play around with things which you're not able with HLS, like faster startup delay, reduced end-to-end delay, detailed reporting using the defined matrix in the standard, and so on. So that's really great to use and see what flexibility you have here. And Orange TV is a great example for DRM protected premium content using the HTML5 EME and using common encryption as the future of DRM in the web. And what are the reasons for them? So as said, native HTML5 support for DRM protected content, for Dash content, and of course within HTML5 you also have a better performance than with more heavier plugins as you're used to use in the past, like Silverlight or Flash. And you can reach a set on devices, not just with web players, also in the mobile domain on Android using Exoplayer from Google, which is a great example where you can also optimize the streaming behavior to your needs, and of course also other implementations. And that's one of the major advantages you have here. With web-based players in JavaScript like Dash.js or BitDash or whatever, or with embedded native players like Exoplayer or whatever, you have a lot more degrees of freedom in your deployment. You can hook into specialized adaptation logics, for example, which fits your use case, your device target group, your bandwidth scenarios, and so on, and can increase the quality of experience of your target users. Here we have one example which we did with our solutions for mobile environments, where we tuned our players to adapt to bandwidth changes which are present in 3G and 4G networks. And as you can see here, we effectively increased the average bit rate which is consumed by the end user just by tuning the adaptation logic. We gained up to 100% higher media throughput values against the standard HLS implementation of Safari, for example, or the HDS implementation of OSMF player. And that are the things you can really leverage today with Dash. And on top of that, depending on the use case and on the expectations you want to raise, you can minimize the startup delay or the seeking behavior just by manipulating the adaptation logic accordingly. The same applies for stream switching. Here we can end up in 80 milliseconds of switching delay or startup delay until the first frame is presented to the user. And that's a user experience which is not known to a lot of consumers today. And you can also hook into certain things which are needed for your use case into the Dash MPD, for example. And if it makes sense, you can submit it to MPEG. And maybe in the future, it's part of the next version of Dash, and you contribute it to an international open standard. And that's the huge advantage we see here. And that's also something which we do on a regular basis. Some further things which we see in our daily work is the flexibility you have with Dash. As David said, you have the flexibility to have closed captions, subtitles, and assemble them as needed to the user context. You can use TTML subtitles for live, you can use WebVDT, you can even go for 6 or 8, whatever you like, you're not bound. So that's the flexibility of the standard versus other solutions on the market. Of course, it's platform independent. You can also always fall back to other solutions, progressive. You can fall back to smooth streaming on browsers which not yet are there, which we frequently see today, especially in the DM field. And in the end, the user gets a higher degree of freedom in selecting the content which he wants or she wants by providing it in the user interface. You see it with YouTube today, and you see it with Netflix today, but also smaller services can make use of that. And also here you can see some things you can do better in Dash, and like we did this add label attribute in the MPD, and we recently submitted it to the standardization, and maybe in the future it's integrated in future versions. Again, a great example of an open standard. And it enables also the roadmap to 4K and UHD with additional adaptation sets and additional representations for these different resolutions, and in particular for the transition towards HEVC. That's something which is in the standard and which is supported out of the box, and where you can deploy these 2 types of codecs today and serve it to the devices which are capable, and fall back to AVC for those devices which are not there yet. And as said, best practices are the best thing for standardization. Participate in the activities in MPEG, in the Dash Industry Forum, in W3C for the HTML5 EME specification, and it's open for everybody, and feel free to participate. Thanks.
Thank you very much. So we talked a lot. It's time for question answers. Any questions from audience? Yes, please.
A question about the HTTP push stuff, what you talked about as far as the latency improvements are concerned. Outside of the changes necessary to implement the push mechanics, was there anything done in your test environment outside of that process? Segment length changes, buffer thresholds, modifications, or anything that contributed to lowering that latency?
Segment changes, yes.
Vishy,
Length.
before
sorry.
answering, let me repeat the question so people on the recording can also hear. So what changes is required to support HTTP 2.0 push in the standards in terms of the segment durations, any type of signaling, any changes of the standard?
So there was, of course, the segment duration change, which is what is key advantage of using something like using server push is that you can actually take the number of take the segment durations really small, and that doesn't affect the number of requests you get. The comparisons, we did a study on the comparisons where tried to were reported, for even number of requests, what is the latency improvement? And the buffers sizes also typically depends on the network and how smooth your network is. That you can do some analysis and figure it out. Those were done outside of the outside of what's in the standard itself, because Dash doesn't specify that. But it was done for both the techniques. It's not just for the server push part.
Very good, thank you.
Questions? Yes, please.
The length of the segments, are they standardized, or are they something that can be scalable depending on the bandwidth?
Are the lengths of the segments or standardized in the case of HTTP 2.0 or overall?
Overall.
Overall. On the Dash standard, the length of the segments, are they standardized or it can be anything? Anybody who wants to answer?
I can take
Yes.
that one. They're not standardized, so you can do whatever you want depending on your target use case. Depends on the target network, for example. If you target a mobile network with high bandwidth changes, it makes sense to go for lower segment sizes, smaller segment sizes, or you go for fixed access networks or whatever with lower bandwidth changes, then you can go also for longer segment sizes. It always depends also on encoding efficiency. That makes a lower boundary of the segment length, and of course also of HTTP settings. If your CDN or HTTP server is not supporting persistent connections, HTTP 1.1 in general, then you also suffer with smaller segment sizes. And so that's heavily dependent on your scenario, and the standard gives you the flexibility to choose the segment size according to your environment.
So in the case of the pool-based HTTP solution, are there any bandwidth concerns with getting more responses than in older versions?
So in the case of HTTP 1.1 pool based solution, is there any
bandwidth concerns?
Any bandwidth concerns?
So it's typically a scalability concern more than a bandwidth concern as to how many you can support.
So it just depends on your network.
Yeah.
And the bandwidth concerns is addressed by adaptations to different rates. So if you have problem with bandwidth, you switch to lower
Scale
bandwidth.
down your bit.
Then we go back there. Yes, please.
In the ad insertion discussion, you talked about user-defined events and being able to queue an ad, for example. Since it's user-defined, can that be used for a wide variety of things? For example, synchronizing rich media with the video?
Again,
So-
let me repeat the questions.
So with user-defined events,
Yeah.
you can queue up an ad, for example, is what the discussion was about. Can you also define other things that you want to synchronize so that you could queue up rich media to be synchronized with the video?
So when you able to queue up ads with the ad-driven events, can you also synchronize other medias with the events?
Okay, so you surely can. This was the whole point of introducing events as a generic framework rather than introducing specifically SCT35. So you can use it for this type of synchronization. You need to define your own URL, and you need to define exactly what is the payload of this event.
Okay.
That's basically it.
Here.
I would like to add to this question. When you user-driven ads, and at the same time you talked about these are defined by the key points. So how's in one you say user-driven, but they have to start playing at the point of the key point?
So the question is user-driven ads versus signaling ads to start at cue points. How this works with each other?
This works perfectly well. Ads are never inserted at random. So from the very beginning, when you prepare your content, you have exact places where you can insert ads. So let's take a football game example. There is the break. This is the only place where you can insert ads. You don't want to insert it in the middle of the game. And then the way you replace this break, the way you put the way you place ads is targeted and is driven by the knowledge that the decision server has about both the user and the upcoming break. So does this answer the question? Thank you.
Okay, next question.
For the HTTP2, is there recommended tools to start looking at how those new protocols work? Or is it really custom things that are only being done in an isolated lab?
So for HTTP 2.0 support, is there any recommended tools to use, or are they developed and designed customly in the lab?
Most of our tools are custom, but the standard browser tools work well with HTTP2 now, particularly for Chrome seems to have good support for HTTP2. So the client tools, you could use the standard developer mode in browsers.
Are you asking whether HTTP 2.0 is being widely supported by commercial browsers?
Well, both client and server.
And servers?
But you answered the client piece, and it sounds like the server.
There are also implementations of servers available. I think if you go look at the HTTP2 or Wikipedia page, there's a list of browsers and clients that are available. But the tool support is coming, and some of them already have, some of them,
correct me, but the design philosophy is that to not touch HTTP 2.0 protocol at all, and to do the minimum change in current Dash specification to be able to support HTTP 2.0.
That's right.
There was another question there.
I'm going to ask the question you probably hear today. What is your view on Apple? We have to produce both formats.
Okay. So what's your view on Apple and HLS? Is this the world dividing between Dash? If everything goes okay, the world will going to be divided in two formats, HLS and Dash? Do we need to support both? Anybody wants to answer that? Anybody is brave enough to answer that?
To be practical, we have to support both. I mean, all of our, I think, products support both. But hopefully, there are enough features and tools in Dash that it will be one in the end, which we hope is Dash.
Any other comment?
So I would say commercially we have to support both. I hope that this would go away. This is less of a technological problem because we've seen that Dash can do more and be more efficient. This is a problem of when Apple allows streaming of non-HLS content over LTE.
And Stefan, you had also a comment.
Yeah, with considering the HTML5 support of Dash using EME, MSC, I think that topic is clear for web. For mobile devices, as long as iOS is not supporting Dash, we have to support HLS. But for all other platforms, also for Android, seeing the great EXO player support there, there's no real reason to stay with HLS and not go for Dash.
I just add one sentence, but this is very true nature of a new format, a new ubiquitous format. When it starts, there are legacy systems that are dominant. So for a while, you have to support the legacy systems as well as the new systems. If the new system truly provide new functionality, hopefully going to be a transitions and a dominance by the new platform. There was a question there?
With the K-push, you said you can configure the segments. So can we configure like let's say I serve the mobile version, and then the server decides that there is enough bandwidth. Will it be able to push within its segment, and like the next higher, or if it thinks it's served 1080p, can it do that?
So the question is again, how the server knows how many?
Now with the K-push, can it serve variable quality segments?
With the K-push, can the server decides to adapt?
Yeah.
Basically, don't send just one representation, K segments of one representation, but switch between different representation.
Right now, it's not designed to do that. But I mean, if we combine something like multiple aspects of Dash, it is conceivable that it's possible. But right now, it just pushes exactly the same representation.
So the client has to then decide, like, isn't it a waste of like
So if you think about it, instead of using, say, 10-second segment, you could use 1-second segment with K equals 10. So it's exactly what you get today. So it's not anything worse in terms of wastage. But then if your network characteristics are not stable, then a lower K can be chosen to begin with.
It's up to the client to decide what K would be. Depends on the network characteristics, decides larger Ks or shorter Ks. And then therefore it doesn't burden to wait for the next huge number of segments to adapt.
But the server already knows, like, you can push higher quality segments or higher bitrate one. But, I mean, so do you have plans to standardize that?
Go ahead.
Do you have do you have plans to standardize the number of K, basically, right?
No. The question is, do you have plans to switch within K?
Between K, the server switches between K. Any logics? Okay, go ahead.
I mean, something that we could definitely consider, but we want to go for the most common use case first.
Any other questions? We are beyond the time. But Jeff, since you are been involved, ask also the last question.
On HTTP 2, does the server know how long it takes to push the segments to the client?
How long in HTTP 2 though?
In order to do the adapting that was being asked about here, the server would need to know how long it took to deliver those segments.
Can server monitors the
I
bandwidth
don't know how the server
in
would
HTTP
possibly
2?
know that in order to make that adaptation possible. Without the client.
With the client.
Yes.
There is no RTSP. There is no RTCP.
Right, so I'm not sure that his question is, or his thing is feasible
Practical.
based on that.
Anyway, so it's we passed our time. If anybody is interested, they can come and ask question here. Also at 6 o'clock, we're going to gather down in the bar here. If people are interested, they can join us and have a drink with us and ask more questions. Thank you very much.
Thank you.